Welcome to the Getting Started with Boat Deck Measurements tutorial. By the end of this tutorial, you will have run a test project and output a sample file simulating the process of modeling a boat deck panel. To follow along, you can pause the video as many times as you want or change the playback speed if you find it moves too quickly. This video will cover the equipment needed, calibrating your camera, setting up a test project, laying out the targets, taking photos, loading and processing the photos in PhotoModeler, and outlining and exporting the deck panel. To start the process, you will need the following equipment. A camera. Most cameras can be used, but we recommend for best results in this order. A DSLR or mirrorless camera with a fixed lens, a good quality camera with a zoom lens, or lastly, a mobile phone camera. When using a zoom lens camera, it can be used only at one focal length. A set of coded target letter sheets. The PhotoModeler letter sheet system is used in this tutorial. These can be purchased with a rubber backing or downloaded as a PDF that can be printed on paper. See photomodeler.com/lettersheets for more information. A measuring device such as a tape measure. We strongly recommend that you carry out the following steps in this video yourself. The best way to learn the system is to try it. Watch the video to see what is needed, and then return and complete the projects using your own cameras and targets. This calibration step is optional, but recommended if you will be performing several projects. The calibration can sometimes be done as part of the final decking project, but to assist with weak projects and cases where it is not possible to get sufficient photos, we suggest doing this separate calibration step as it can be reused with all future projects done using this camera. We recommend you do this calibration as part of the learning process. To perform a calibration, lay the letter sheet targets out in an area with enough space that you can walk around them. If you are using paper sheets, be sure to tape them down so they do not move between photos. Good lighting is important. Use a flash if the lighting is insufficient. While a fixed, non-zoom lens is preferable, if you are using a zoom, set it to the widest angle and do not adjust it. The calibration will only be valid for this zoom setting. At a slight angle, take 3 photos from each edge of the target grid. 1 landscape, 1 portrait rolled to the left, and 1 portrait rolled to the right. As you take the photos, try to line the bottom of the grid along the bottom of the viewfinder. Try to make all the targets visible, but also have them fill as much of the frame as possible. For some of your portrait shots, this may mean some of the edge targets are not visible or are cut off. This is okay. All targets do not need to be visible in all photos. Once you have taken all 12 photos, load them onto your computer and start PhotoModeler. When copying the photos from your camera, make sure it is done at the maximum size, full resolution. Select a new automated target project. Add your 12 photos to the project and choose the option for camera parameters solved by Smart Orient Auto Calibration. After pressing Next, the targets are detected on each photo and processing runs. Processing solves the camera's 3D position when each photo was taken. And, with the auto calibration option chosen, it also calculates information about the camera, such as the lens focal length and distortion. All 48 points and 12 photos should be solved. Distances are calculated in a relative fashion. While this is fine for camera calibration, your future deck projects will need an absolute scale. This scaling is done with the letter sheet presets and known distances between these targets. We will configure that now. On the Create Targets tab, open the Coded Target Presets dialog. Choose the letter sheet preset in either millimeters or inches. If you would like to use different units or a different set of scales, you can create your own presets, as shown in other tutorials. Clicking Apply Configuration locates the targets and defines the distance between them based on the preset. If you'll be using letter sheets in all future projects, you can choose the Use in Auto Projects option. Choosing this option will mean that future coded target projects will automatically apply this preset. We will choose this now, and you can see it in use when we run our test project in the next part of this tutorial. The project is now solved. We can open a 3D view to see the solved 3D points and turn on camera station visibility to see the solved photo positions. One metric to review is the maximum residual. Aim for a value less than 3. We will save the project, and the calibration can be loaded from this for use with future projects. Or, to have the calibration automatically assigned during future projects, it can be added to your camera library. From the Review tab, open the Cameras dialog. The calibration process calculates the values displayed here. These are why the calibration step is important. Click the Library button and select the camera. Then move the camera into your library. That's it. We are set up and ready. However, before you start taking photos of boat decks, we will run through a training project so you're familiar with the procedures and requirements. To ensure your success, it is important that you run through this test project step and become comfortable with the system before working on a boat. We recommend you try this project with your own camera. Create a sample setup by drawing a simulated panel of boat deck on a large sheet of paper or cardboard. Outline it on the floor using tape, or here we're drawing one with chalk. Make sure the surface you use is flat. Complex 3D surfaces use other techniques. Here we will focus on flat panel modeling. Let's start our test project. Place targets inside the panel area. If you're using paper targets, be sure to tape them down so they do not move between photos. Here, we are using rubber-backed letter sheets. Cover the panel area in targets. These targets define the plane that the panel is on. Letter sheet A defines the XY plane used for flattening, and so it should be placed on the surface of the panel. Then add additional targets placed around the outside region of the panel. These targets do not need to be at the same level or angle as the panel. The extra targets around the outside will provide increased coverage across the photos and help improve the tie and spread. When outlining the deck panel, it is best to use straight-down photos. So we start our photo set taking images looking down on the targets and panel. Move the camera between each photo. Don't just stand in one spot and rotate or roll the camera. As the camera moves, make sure there is overlap between each photo and the next one. As the camera moves, there should be a shared set of targets between each photo. Try to capture as many targets as you can in each image. Aim for at least 10 or more targets per photo, covering as much of the imaging area as possible. We could trace the outline using the first set of straight-down photos, but it will be easier to use this final top-down overview photo that captures the whole outline in a single top-down image. This is a minimal set of photos. You can always take more from varied positions. The general process is to take a series of straight-down photos that will cover the panel, and then a set of slightly angled ones that create a circle around it. This redundancy can help in the case where there is a problem with some of the photos, like motion blur, and provides additional angles to help the solution. Now we will take some measurements between the centers of the targets. These measurements are not required as part of the process, but are to confirm your solution. Be careful not to move any targets while taking measurements. Often, PhotoModeler's results are better than casual use of a tape measure. So, for a valid comparison, make sure your measurements are accurate and precise. If you were modeling several panels on a boat, you could now move the targets to the next panel and repeat the steps. These additional panels would be run as separate individual projects. Load the photos onto your computer. When copying the photos from your camera, make sure it is done at the maximum size and full resolution. If the images must be emailed, do it as full resolution attachments, not embedded in the message. Start a new automated target project. Add the photos. Because the camera calibration was added to the library during the calibration step, it is automatically matched with the photos. Choose Yes, Use Matched Camera, and the processing will begin. If the camera was not found in the library, this pane would be displayed, and you could either load a calibration from an existing project or run an auto-calibration. Auto-calibration means PhotoModeler calibrates the camera internals at the same time as running the project. The auto-calibration option should only be used with appropriate photos as described elsewhere. The set shown here would be suitable for auto-calibration, but when possible, it is best to reuse an existing proven camera calibration. The auto-marking stage of processing detects the targets and codes on each image. These marks are used by the orientation stage to solve the position where each photo was taken, and these photo positions solve the 3D location of each target. The preset that was selected to use in auto projects has been applied, and the results of the scaling are shown. Comparing measurements is not mandatory, but it's a good check as you're learning. Opening a 3D view and turning on Camera Station Visibility shows the solved 3D points and camera positions. Everything, including the project scale, has been set up automatically. Open the measure pane and the photo showing the measured points. Select a point at one end of the measurement, hold Shift, and select the point at the other end. The distance between these points is displayed on the measure pane. This solution can now be used to define the plane of the outline. Select the points on the plane of the panel. This can be done in Select or Region Select mode, on a photo, or in a 3D view. With the point selected, choose Best Fit Plane from Selected. The resulting 3D plane can be seen in the 3D view. To account for the thickness of the rubber back panels, select the plane, open up its Properties pane, and offset the plane by the thickness. The rubber back sheets are 4 millimeters thick, so we enter -4 as the plane offset value. The plane will now define the position of the sidewalk, and this can be used for outlining. Using a top-down photo, trace the outline. Switch to Surface Points Curve mode and click on the photo to start outlining the panel. Since the plane does not extend this far out, a prompt allows you to trace using the closest surface. Continue clicking to create a curved outline of the panel. Scroll the mouse wheel to zoom. Click and hold the wheel to pan the photo. For additional tips and more advanced cases, such as using multiple photos to create the outline, see the additional tutorial videos. Clicking on the point the curve started with closes the curve and ends the curve draw. The final 3D curve can be seen in the 3D view. You can also see the 3D curve projected on each photo. Viewing the 3D curve from the photos taken from different angles is a good way to verify the surface and solution matchup. This outline can now be exported for use in CAD. Go to File, Export, Export Model. Select the 2D DXF format and output only surface draw lines and curves. The Settings pane can be used to control if the output file writes the curves as splines or polylines, as well as other DXF-specific settings. For most projects, the default XY flatten plane is best. The flatten report shows the minor impact flattening has on this curve. Here, the final export is shown in another CAD package. This can be edited or used for cutting. That concludes the Getting Started with Boat Deck Measurements tutorial. This video has covered the equipment needed, calibrating your camera, setting up a test project, laying out the targets, taking photos, loading and processing the photos in PhotoModeler, and outlining and exporting a deck panel. It is important to learn this process before attempting a project on a boat. Try these test steps yourself. If you have problems, don't hesitate to contact support@photomodeler.com for any guidance or to share your project. These same steps can then be applied to other deck panels on a boat. After you have success with this, similar steps can be used for multiple panels at once or even a whole boat.